G'day, Max here again, welcome back to the shop. Well, we'll start off with, we had a letter came in from the USA, from Alabama. So with it's a nice note as well, and that's from Anthony from Ragsdale Creek Workshop. So here's Anthony's channel sticker, Ragsdale Creek Workshop. If you haven't already, might be worth popping over and having a look and maybe subscribing to his channel. He's just got a small channel going there, so yeah. Thanks Anthony, cheers, we'll get you up on the board. Now, today we are going to make a lead screw protective cover. So I've got a couple of scrap items of aluminium here. I was going to make a sheet metal one, which would be quite easy, just to roll a piece around and MIG weld a bracket onto it, but no, we've got to do it the long hard way. So we'll fabricate up an aluminium one, and I'll swing the camera around and I'll show you what our basic design plan is. Okay, there's Anthony's sticker up there, Ragsdale Creek Workshop. You're in good company there, Anthony, below Adrian over in the UK, and Dean there next to you from the Air Cave shop, and a whole bunch of others. So it's coming up time, I might have to extend our sticker board for a larger one. Okay, so our plan will be to get the piece of aluminium tubing, cut it to 3 inches long, or a bit over 3 inches, maybe 4 inches. We'll slit it in half, so half will sit on top of the lead screw, and then we'll weld a skirt that comes down a little way and comes along, and then a bracket which comes out and bolts to the face here. So we'll get our aluminium pieces cut up and head over to the welding bench. So I have a piece of 50mm tubing here. So what I want to do is cut this in half for a length of approximately probably 120mm. So I'm just eyeballing 25mm to the edge of the tubing, just using the gudgeon pin, which I've got. That's set there. So we lock off our cross slide, lock off the that way. Okay, come up on the knee. I just got a 6mm slot drill in here, just 2 fluid end mill. Alright, we'll take a cut down and see how it goes. Make sure the machine is in gear, if it wasn't. Okay. Aluminium, so we can run this pretty quickly. That's sitting on 2000 RPM there. Pretty well WD. chip brush. Gone. Okay. What I'll do now is I'll rotate that round half a turn, and that'll give us a half circle piece for the top cover of our lead screw. Okay, so our second side is just a repeat of what we've done on the first side. So all we've done is rotate the part 180 degrees and measured in our 25 millimeters from the edge of the part to the edge of the cutter. Okay, so all we do now is cut around there, and we have our half piece which will form the top cover of the lead screw. is our top cover. We'll get this cleaned up and then make the front plate. Okay, so I have this bit of off-cut cast aluminium. Originally it was off the lathe, off the what formed part of the guard for the motor drive pulley, but when I fitted the other motor I had to modify the guard and all that. So what we'll do is we'll trim this bit off-cut here up into shape, because this will end up getting basically welded on like that. So I'll just clean up across the top, and I might just skim a bit off one of these faces just to reduce that thickness. It's got a bit of, I've just been playing around with my TIG welder, that's the first time I've done a bit of any alloy welding with my TIG welder. So that's not too bad considering it's a bit of cast old crap. So anyway, we'll get this trimmed up and we'll get it welded to this. Okay, we'll just chop it off to length now. These are really good, these jobs. There's no setup, there's no real sizes. Everything's just eyeballing, so here we go. Okay, I'll just deburr this and we'll get it set up. We'll just take just a light skim cut across one of the faces. Just as it's a wedge shape from the casting, we just want to thin it down to 1/4 of an inch thick. Okay, yeah, we've got a bit of ringing going on there because this is a Morse taper 3 ER32 chuck in an R8 to Morse taper 3 adapters, so you get all this extra overhang and it just gives you a bit more ringing, so that's how come we knocked our speed back to 1000 RPM. So we'll get this cleaned up and we'll get it tack welded onto this part. Okay, we're set up in the vise, we'll get a couple of good tacks on it. I've had to resort to my old welding helmet as my auto darkening one. The battery died in the arse, so okay. That'll hold it. Let me go and just do a quick test fit on the lathe, and if everything looks good, then we'll do a weld along both sides. Okay, we'll get our first run along the rear of it. See how we go. Okay, time for side 2. Well, that's not that bad. We'll let that cool off and we'll take a look. Well, okay, there's our first side. Yeah, it looks like a bit of chook shit. And we have a definite improvement, I think, on the second side. But bear in mind, that's the first time I've ever done alloy welding on that welder. I've only done 5 minutes of alloy welding on another welder in my entire life, so I think we're on the right track. So we'll smooth it. This will all get buffed off smooth anyway. And so what we have to do now is swing around to the lathe. This will form a bracket which sits up inside there. So we just make a mounting bracket. So that'll keep all of the dirt and rubbish off the lead screw and the half nuts. Okay, cool that off and we'll have a look. I can see one bit where a bit of rubbish has come out the aluminium there. Just there, because this is the like a Asian cast. And that's just alley plate. Yeah, just there. Okay, there's our completed cover. So that should keep the chips and crap out of the half nuts. So this cover extends inside about another 1 inch and butts right up against the half nuts. And this hole here, we still have our adjustment for the ball detent for the screw cutting lever there. Yeah, so I think it looks the part. Probably a bit flash for this lathe, but I tried to maybe go along the lines of what would be done on a older English lathe or American lathe, just to sort of, so it didn't look too tacky. I was going to make a sheet metal one, but no, I changed my mind. That would look a bit too cheap. So there we have it. Okay, we've got our bracket back in the mill again. We're doing a bit of a modification. What's happened, what I think is going to happen, because we don't have a great deal of clearance between here and the rack. I think chips will build up here and then head towards the rack. So what I'm going to do, I'm just milling a pocket out of here, and I'm going to reverse, I'm going to do an upturn. We'll get another piece of this tubing and cut another piece, and we'll weld it in so it comes up and turns up the other way, and that will tuck up underneath the bed and keep everything out of the rack as well. So it should be alright. So what we'll do now, we'll set this up, and our other piece will have the opposite turn and come back up the other way. Okay, so we had to modify our part as we mentioned before. So we put this upturn on it like a whale tail. So this will keep any swarf chips away from the rack, as we discovered that was what was going to happen. So yeah, we'll clean up the weld. So well, we're improving on the TIG welding. What's the other side like? We're getting there, so I probably won't do any again for ages now, so I'll have to sit down and have a good practice one day and suss it out. But no, that's good enough. We'll polish that back and refit our bracket. Okay, here's our modified chip guard. So now anything comes straight off, comes down and straight off the side. Whereas our first version with the curve, I think that we'd be susceptible to a build-up of chips between the curve and the rack. So this way everything's protected in that area.